I built a Googol gear ratio using Legos. A Googol is one of the largest numbers most people can imagine. It's written as 10 to the power of 100, which is a 1 followed by 100 zeros. That number is so massive that it's almost impossible for the human brain to truly grasp its size. One reason is that almost nothing in the real world even comes close to it. So let's try to put it into perspective. Think about the number of atoms in the entire observable universe. That sounds huge, but is it enough to reach a Googol? Surprisingly, no. Scientists estimate there are about 10 to the power of 80 atoms in the observable universe, which is a 1 followed by 80 zeros. That's an unbelievably large number, but still far smaller than a Googol. So what if we imagined multiple copies of the universe? How many would we need to reach a Googol atoms? We would need about 10 to the power of 20 universes. That's 100 quintillion universes. Now, how can we physically represent a number this big? One way is by creating a gear ratio, where the first gear must turn a Googol times for the final gear to rotate just once. For example, combining a 40-tooth gear with an 8-tooth gear creates a 1:5 ratio. If we keep adding more gear stages, each one reduces the speed by another factor of 5. By stacking enough of these stages, we can reach a total ratio of 10 to the power of 102, which is even larger than a Googol. What you're looking at right now is a Googol ratio in motion. For this last gear to turn just once, the first gear would have to spin more than a Googol times. Imagine filling the entire observable universe with grains of sand. Every galaxy, every star system, every empty space completely packed with sand. That would give you about 10 to the power of 90 grains of sand. Sounds enormous, but a Googol is 10 to the power of 100. That means even one full universe of sand is still far too small.